respect to the lesson.
Pardon?
I have some questions, but I don't think it's on the more one, but it's when I was going through the lessons. I just
Oh,
have some questions I actually need clarification.
all right. No question for demo one, but you have some other questions. They are all welcome. You can ask them.
Okay, when I was going through the non-parametric test
Mm-hmm.
for the methods, you made us to understand that the non-parametric test there is a small sample size and it has to be categorical outcome. That's ordinal sample.
Yes. Or nominal.
Then now or nominal. Yeah, but the example that we looked at, it concerns like those course taken for a new lesson before and after. Meanwhile, course can be continuous or discrete. I don't know why we applied the 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 Wilcoxon test for those courses. Meanwhile, the data was not actually nominal or ordinal, but it was instead a numerical variable.
Yes. In that case, the variable were ordinal, and in SPSS we'll code them as categorical ordinal
That
because
the score from 0 to 50 is ordinal.
normally scores in the test are supposed to be ordinal now. They are ordinal, and in strict sense they are discrete. In the strict sense they are discrete, which means they should normally be continuous variable. But that one is a special case. You can use that also, especially when it is not normally distributed. Yes, when they're not normally distributed, you can use them for the Wilcoxon test, and you specify that your variable is what ordinal, because normally those scores are ranked, because somebody who has 8 over 20 cannot be put at the same scale with somebody who has 16 over 20. So normally they should be ordinal. And if they're not normally distributed, you should normally use the Wilcoxon test. If you're comparing results before and after a particular maybe training or a particular talk that was given to the students and things like that. Does it make sense?
Okay. Yes, I get the point. Because I was seeing it in the sense of discrete. That is, it's okay. I understand now.
No, they're in the sense of ordinal in that particular case.
Okay.
Yeah.
So, and also, I wanted to ask, is it okay, like, for example, the for the chi-square test, is the method to understand that it can be applied for sample space 100 and less than 500. And was it necessary to mention the fact that the non-parametric test applies for sample space less than 30? That's, will it be okay if I want to like carry out a judgment of whether to apply a non-parametric test or not? You just look at the sample space and you conclude, or you must check all the other conditions before concluding.
Yes, you have to take all the other conditions. The sample size is just one of the criteria, and it's not even in all cases. In some cases,
Okay.
in some cases, you can have a continuous variable that has just a sample size of 30. For example, if you're doing a pilot study and you're taking people's weight or height, and you have just 30 participants, you cannot turn it into categorical or non-parametric because you have just 30. So it's just one of the cases. The problem is that when you go to a huge sample size like 500, as I was saying in the case of chi-square, the test will almost always be significant. You can have five, you can run for five different variables and you have about four of them being significant. And it is not because they are actually significant, but just because of this huge sample size. So the test it kind of twist the test, kind of make some kind of control the test instead. Rather than the test controlling it, you would rather control the test. So it is not really advisable that you use chi-square when you have a large sample size of 500 and above. When you have such a sample size, you should think of using things like maybe Pearson correlation, Spearman, some of those other things.
Okay.
Mhm.
I think that was all for now.
Okay. Have you reached parametric test? Have you done anything on ANOVA?
Yes, 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 I've done just the dependent and the independent for parametric test. The,
Okay. That one is easy, right? Have you seen where to apply it in your own industry or in your domain? Any of these that we have done or that you've gone through?
no, not yet. Uh,
Okay.
Someone like Anmata will maybe apply it later. But now I'm just grabbing the knowledge. Maybe it will help me
All
later.
right.
But the exercise you get, this the motivate. I actually try to understand how to relate it with it.
Okay, that's great. So it means that when we will do it today, you will understand it much, much better. And that's the essence, is practice. Once you practice and ask questions like this, you understand it. And when you have to use it tomorrow, even if you have forgotten some of the details, you know where to go to. You go to the YouTube page, you look for the video, you watch it, you can get to me inbox, you can search online. And if you want to do your own research now, you want to do your own your research for maybe your master's degree or PhD, or for someone you want to design a research article to work and publish, you will now be looking at the analysis part of it, and that will guide you to draft your objectives to suit the kind of analysis you want. Because most of the time when some persons or researchers come with data, I feel like I need to change some few things in it to really make it come out. But then it's already late because the protocol has been approved and things like that. So it's very important. So again, you understand the variables. Dependent variable is the variable of interest in your data set. What do you want to find out? What's the problem you want to solve? That thing that is that problem, that's your dependent variable because it depends on all the other things that are causing it. For example, if your problem is alcohol, if alcohol is damaging lives in Cameroon, which is true, I don't know what you think. I think it's subjective. And that is your problem. So you may be going out to find out now how many Cameroonians are consuming alcohol. That is your dependent variable. It's that alcohol. Then the other things now, maybe their income, their mental health, because people consume alcohol for mental health, marital issues, maybe just for pleasure, all those other things now, the age, sex, you know, all those other things that are independent variables. Because without the alcohol, they will still have their jobs, they will still be working, they will still be in the particular age group, you know, they'll still maybe have their stress and they want to cool it off. So like the name just explains what it is. Independent variable means that on its own it can stand. On its own, somebody has their age, they have their sex, they have their income. But now, do those things influence something? That outcome that those things influence, that's a dependent variable. I'm saying so because we are coming to this data, and if we want to understand this data very well, this demo theory, the first thing is we pick out the dependent variable. Yeah, the first thing is that we understand if they are parametric, the variables there for parametric tests, or if they are categorical variables there or continuous variables. Once you pick that out, the second thing is you pick out if you pick out your dependent variable based on the specific objectives that you have, because you may have to use two or more dependent variables depending on what the question that is asked or the objective you want to attain. Okay, so I think I'm going through this. Okay, we'll just go through again. For you, Madam and or Mr. Prince, do you have any other question? Let me just go through straight to this without asking.
No, not for now. Yeah, I'm
Madam
good.
Anne, did you go through any question?
It's like her line is disturbing. Okay.
She's muted.
Yeah, it should be network because she's not connected, even on WhatsApp.
Okay, I see. All right. Anyway, we're recording the call. I think she'll be able to go through. So we have the mental health, maternal health, and neonatal outcomes. This is strictly medical. Most of my data sets are medical because 90% of the researchers I've worked with, they are from the health industry, and it's because I'm also from the health industry. Although I'm kind of migrating and differentiating to get to finance and humanitarian work, but my primary industry is the health industry. That's why most of my data sets, the real world data sets, you always hear things about health. Well, but I tried for the one for the sickle cell, right? I think we kind of move a little bit outside. We went to the council, look at things like income and that social factors. So this one is strictly medical. Okay, so we have maternal health is about pregnant women, right? And breastfeeding women, yeah. Then neonatal outcomes is about the neonatal I talk about the babies. Like the outcome is after the baby has been put to bed. What was the weight of the baby, maybe the sex of the baby, maybe the what they call Abga score. Is the baby breathing well? Did the baby cry well? All those kind of things. So that's not these are critical factors or indicators of community well-being. And factors such as maternal age, because the age of the woman also matters in pregnancy. Yeah. The woman's body mass index. Women who are very pale or very, very, very big, they may that will influence their pregnancy outcome. They always say that women who have a lot of fat or adipose tissue may have some complications, or the baby may be very, very slow, or they may give birth to baby with low birth weight and things like that. So parity here is now the number of times the woman has given birth, the lifestyle behavior like alcohol and mode of delivery if it's vagina or was through operation, or that's what we call CS. And they are known to influence pregnancy outcomes and child development. So if we understand these variables and how they interact, it can provide valuable insights for improving maternal and child health services. And most of these things that have been implemented by WHO or Ministry of Health, they are actually from research that people have carried out and reviewed the results that has led to what? Change in policies. Okay, so we have the data set presents information on 255 mother-child pairs, capturing, that means each mother and her baby, capturing maternal socio-demographics, their health-related factors for pregnancy history, and neonatal anthropometry, that's maybe their arm circumference and other things. Key maternal variables include age, marital status, tribe of origin, gravidity, number of times I've been pregnant. This is gravidity. Parity, number of times I've given birth. Because you can be pregnant 5 times, but you give birth 4 times, right? Because, I mean, the term, put to bed at term at 4 times because of miscarriages and maybe other things. BMI and alcohol consumption. Oh, it's even there. While neonatal indicators cover birth order, the child can be the firstborn, secondborn, or thirdborn. The gestational age, it may not be up to 9 months, maybe 8 months, 11 months, can be more than 11, 9 months. Birth weight, length of head circumference, and other things that we may not look at in this data set. So with the richness of this data, researchers can explore how maternal characteristics influence neonatal outcomes, assess patterns in delivery methods, and identify risk factors for low birth weight or abnormal anthropometric growth. This makes the data set particularly relevant for studies in maternal and child health, perinatal epidemiology, and public health interventions. Using the guides below, analyze the data in SPSS and submit your results. What I've like maybe I'm not really following up, I don't know, but normally we had to analyze it and submit our results either by email or by WhatsApp. That's how it's this thing was pictured to be. This is our course. So that when I evaluate, I can know your strength already. And I kind of gave some hints.
Yeah.
I gave these hints because I realized that it's still maybe too early for us to go to um judging, analyzing which test to use. So I gave the hints myself. But normally I was not supposed to give these hints. Suitable test, suitable test. I was not supposed to give these ones. You are supposed to judge from your skill, from your theory, and the practicals we've had and be able to, you know, come out with a particular test. But notwithstanding, we'll see how it goes. I mean, so the first one is compare the mean birth weight of newborns delivered by vagina delivery versus cesarean section. When you hear the word compare means, just from these three, you compare the mean. You already know that there's a test in SPSS called compare means, right? Which is t-test. So the only thing now is to check if your data meets the criteria for t-test because each test has its specifications. So compare the means birth weight of newborns delivered by vaginal delivery and cesarean section. And the thing here is that you have to understand why you're doing it. How will it help you? Because at the end of the day, you want to inform public policy, right? We want that government should change policies. The ratio can bring in new guidelines. Research must always end up somewhere. Unfortunately, most students do research and it ends up in the library in their schools, which nobody will ever read, if at all. People read. But normally it's supposed to inform public health. All right, so we'll look at the data and we'll export it to SPSS because it was an Excel file that I sent that I shared. So we have to export it to SPSS. All right, can you see the data I'm sharing?
So,
Pardon?
yes, I'm seeing the data.
Okay, so you see that we have the patient code. The first thing is to understand the data. We have the mothers. This is the date of birth of the mother. This is the age. I think if you just take 2025 and minus this one, you should have this age. Then this is the maternal age range. It was already classified in the data set, as you can see. 25 to 35, 14 to this. Let's see how it was classified. 14 to 25, 25 to 35, and 35 to 45. All right. Marital status is there. Tribe of origin, tribe of residence, gravidity. Why are we having two gravidities? Okay, this gravidity grouped. One is grouped. Parity group, the weight. These are the weight of the mother, as you can see here. Weight underscore mother. And then we have the height of the mother. Then from here, you can get the BMI, which is already here. You can classify the BMI. BMI class, is it normal, overweight, obesity, alcohol use, yes or no, alcoholic index. I don't know. Medical doctors know how they got this one. We might not need it. Then the term, was the baby born at term 2 or post term, gap days. Maybe this one is the number of days. I don't know. For
Gestation period.
gestational, I don't know what this gap stands for. I forgot.
That gap there is just gestation of a baby. That
268.
that 268 days. If we divide by 30, we have the number of months.
Okay. Is it up to 9 months? Yeah, I think so. Because 12
No, it's
months is
not. It's in, yeah,
12 months
it's
is
8 months
360
something.
something. Yeah, maybe this one was less than 9 months. Gestational age, the range, the mode of delivery, vaginal delivery. And then we have age at recruitment, birth order, birth weight in grams, birth weight in the class, then birth weight class 2, full length, hair circumference. These are all the anthropometric measures. All right, I understood the data. We're saying that our mode of delivery here, we have vagina and cesarean. All right, I'm going to see. So we go to SPSS and then we import the data. So this SPSS, can you see?
Uh,
All right, so I always like to use from file, take open, and then I click on data. And then I will go and choose that I'll locate where the file is saved in my computer. That file is saved under its projects. And under its projects, I have its analytics, its analytics business strategies. Then I have SPSS course and it's demo 3. And if I click on demo 3, I'm not seeing anything because the file type that is on my SPSS here is an SPSS file type. But what I want to upload is an Excel file type. So you must come and change it here. This is where most people get stuck. You must come and click here and choose Excel. Once I choose it, you see the Excel has popped up here. And it's only Excel file in that folder. If there are many of them, you will see all the Excel files. So I'll click on it and I'll take open. And of course, my headings were on the first row because they'll ask me that read variable names from the first row of data is checked since our variable names are on the first row. If they're on the second row, you can uncheck this one. The percentage of values that determine data type. So SPSS will determine a data type based on if 95% of your data meet a particular criteria. Is either string or ordinal or what. SPSS will struggle to identify it for you. Then ignore hidden rows and columns. If there are rows and columns that were hidden in SPS in Excel, as always hide a column or hide a row. So that's saying that they should ignore them here. If you don't check this ignore, it will pull them up. It will pull all the hidden rows and columns up in that particular data set. Remove leading spaces from string values. This one is not checked because we want that if there's any space in a string value, it should not be removed. That means the data should not be joined. But this will still happen in the variable names because SPSS will never take space in the variable name, but at least in the variable label, it will not do that. So remove trailing spaces from string values. These are spaces after what the string. So if you want to type maybe male and female, then you type male and then you mistakenly type space after that male before it goes to female in the next row. It's recorded in that computer as it's different data is a different thing you have done because there's space after that male. And that's sometimes give problems in the data cleaning because you realize that some things like this male is spelled the same as male, but it's seen as two data types. So you have to go and check if there's a space after the male or there's space before the male. All right, take OK. And our data set screen sharing has stopped as the shared window is closed. So I will reshare this one. So I come and share this one. All right. So this is our data and SPSS has struggled to identify the data types just as we saw when we were inputting it. So you see that the patient code is seen as numeric and is seen as a scale. Why date of birth of mother is seen as date, you see now, data type date, and it's day, month, year. I don't know if that's how we got it. You can check it. 28th August, SPS has changed it to suit its own date format, right? Then maternal age, we're seeing a string here. Marital status string. Maternal age here is a scale now. This first one is a scale. Did I see it well?
Uh, if someone fails to identify the variables very well, does it affect the results? Like when you have those scales and nominal variables like that.
Yes, some some statistical tests will not take string. Why even still here? Why even still here? For example, you see this string here, this maternal age string like this. If you want to run some statistical tests, I mean, even things like ANOVA or regression, they will not accept the string. So you must code it and come and change the string to maybe a numeric. And then some tests will be calculated based on the measure here. If it is scale and you choose nominal, because this one, nominal means it's categorized also. All right, in 10 minutes.
Yes.
So if you have maybe this age here, let's say this age that everybody has their particular age, it has not yet been categorized, and you come and choose
Mm-hmm.
nominal. When you run something like maybe chi-square or something like this, SPSS will go to every single age and give a unit for and give an answer for it. So out of the 500 and how many
Uh,
things? 500 answers because they are seeing those different things as what? Different categories. But
okay.
if you had chosen it to be scale, it will just give you the mean because it knows that no, this is a continuous variable. So it's important to always check if SPS has done the right thing for you. And of course,
Okay.
this one's as a string. This string like this, if we are not going to use it to do inferential statistics, we may leave it like this. But if we are going to use it, we'll simply come here and recode it. Convert all these things to 1 and 2, 3, and then change this string to numeric. If at all we're going to use it in our data set to do inferential statistics. If you use it just for descriptive, just to know how many people were married, how many without doing anything that needs p-value, you can simply just leave it and then do your frequency tables. All right. Then so we look at it, but what we really need to for our specific objective one, what we need is the birth weight of newborns, right? Delivered by vaginal delivery and cesarean section. That's our interest. So we should just look at those two variables. So I want to see birth weight, that's of the babies, and no, I don't want this. Birth weight, I think this is it here. This is birth weight, and we can see that it's numeric and it is a scale. No, it's showing nominal here, you see. Is it the birth weight categorized? No, this is birth order. I'm in birth order. No, 24, 25th, number 25. So it's birth weight. All right, let's look at it. Numeric and okay, scale. All right, that's fine. Of course, if you go to the data view by double clicking on this 25, the column will be highlighted here and you can see that this is the birth weight and it is in grams. And it, of course, is continuous. As you can see, each person has their own weight measured in grams. All right, so the next thing is the mode of delivery. And our mode of delivery here is going to be a string. So we have to code it because when we're doing um, test, we're comparing the mean. This one, we're comparing this mean birth weight among two groups. And those two groups need to have quotes because when we're doing that, we need to put those quotes in SPSS under values. So if we look at which variable has the birth, the mode of delivery, this is 22. Mode of delivery here is string. And since we want to do t-tests, it is better we convert it to what? Numeric. Although it is string because it's either CS or vaginal delivery. Yes, it's a string. But in the context of statistics, we'll convert it to maybe 1 and 2, but we'll come here and tell SPSS that this one like this means maybe CS and this 2 means vaginal delivery. Just to suit our software. So how do we do that? This one is the only one that is not yet automatic or we made automatic. We have to do it manually. But if your data was, if your spellings, oh, who's calling me here? Please 1 minute. Let me just. Okay. Let's continue. All right. So, but it's easy. You don't need to go through one by one and be changing this vaginal delivery to 1 or 2. If they have the same spelling, you can simply replace. Okay. So these guys, they're just calling me. They don't know that this Saturday. We don't work on Saturdays. You cannot give somebody to. So what you do is that you can take Control F like just like in Excel, right? Find and replace. So Control F. What's going on? Voila, Control F, and then you click on replace. So we type just as it is, but the best way is even to copy it. The best way is to come here, right click, copy it, and then you come and paste here so that you ensure it's the same spelling. So we are changing vaginal delivery to 1. I'll just write 1. I'll click on replace all. So you see 147 replacements were done. And you can see here. Then you must highlight the column. Please take note, the variable. In this case, they are variables, not columns as Excel. So you don't need to click on it. Just click on the variable name just once. If you double click, it will take you to variable view. You just click on the variable name once. In this case now, we are going to copy cesarean delivery. Let me, oh, la, la. Click on it. Then you come here, highlight this one, you paste it, and then you change it to 2. And you take replace all. Voila, we have coded that one. Then you need to now double click and you come to variable view and you change now this type, this string type, you change it to numeric. Since you have changed to 1 and 2, it's now numeric. Then you come now to values here. And then you say that one that we gave like that meant, what was one again? Cesarean delivery or vagina. Vagina,
No,
right?
vagina.
Vagina delivery. Then we take at. That two like that was cesarean. Oh, we'll just say CS now. We'll say CS. Then add and take. Okay, voila. So you have coded your birth, mode of delivery, and now you want to do your t-test. But now t-test is a parametric test. You must check if your continuous variable is normally distributed. And our continuous variable in this case is birth weight, and that's our dependent variable. Because that's what we think that this the baby being delivered vaginally or through CS was because there was something wrong with the weight or good the weight, which means the outcome is that weight. So that's our dependent variable. Right. Or it can still be reasoned in another way. But let's just take it that way. It can still be reasoned that the baby was put to bed vaginally because the weight was much or small. So let's just reason it this way. And then we check for normality. I think we have not yet done an exercise on this, and that's why this class is very important because the only thing that you have seen on this is solely when you were doing ANOVA. For those that watched the video on ANOVA or ANCOVA, when we did a test of normality. Test of normality means that is your data normally distributed, which means does it look like a bell shaped? All of us know this bell shape now, this mountainous shape where data points begin small, then they increase, they reach a peak, then they start dropping, then they come down, and then they go towards the line. That's a normal distribution. And it is what this is needed to run. Let us write on. So, and when we plot the histogram, you'll see what I'm talking about. So to check for normality, you are going to come over to analyze. You see this in the videos as you watch along. You analyze. So there are two tests for normality that you can check. So we call a Shapiro-Wilk test of normality, and there is a Kolmogorov-Smirnov test. When we do this, the two will appear. You can choose anyone. They have the same interpretation. I always prefer the Shapiro-Wilk. So I am going to go to analyze. I'll take descriptive and I'll use take explore. So in this case, you're not going to frequency tables, you're not going to descriptives, you're going to explore. And once you are on explore,
Wait,
how we can
what?
see, yes,
Yeah, it has switched. I don't. I'm just saying that the those variable view.
let me check again. Let me reshare. Can you see now? It's a variable view, but I was already at the level of
You
analyze. I took analyze. I don't know if you
you
can see.
still the,
Can you see what I'm doing? There's analyze. Then I'm following from descriptive. After that, I'm taking explore.
no, there's nothing that's
Reading.
moving. The thing
Go
that,
ahead.
All right. So you don't see something like let's
nothing.
The
The
cursor is
cursor is
hello.
yeah, that the
yeah,
cursor is
the cursor is
normal.
not moving.
I don't know what's going on. So look at the I've sent an image in the group. So you don't see this pop up. You don't see this analyze
Mm.
this descriptive. You don't
Yeah.
see these things on your
No,
screen.
it's not.
Could it be network or the Zoom has changed because um
That's what I'm saying.
Maybe it's network.
I think maybe it's network or is it because we're using a free version of Zoom? What is the reason why I don't use Google Meet? Because Google Meet you are showing something and nobody sees it. So let's just hope that I'll be able to rectify the issue with my bank. So I'll
So
renew my
stop
subscription. I
the
can see your image, Mr. Prince, and it's true. You can't really see what I'm doing. Okay. I believe that since they say we are recording it, we are going to have um okay. Let me just explain. But if you have it open in your own machine, you can just go walk along. All right, so I'll go to analyze. I'll take descriptives and I'll take explore. Explore. Oh, let me just start it over. Maybe the recording wasn't going through. So it's analyze, descriptive, explore. Then when I'm on explore, I'll look for the variable I want to check for normality, which is birth weight. I'll send it to dependent under statistics. I'll just check outliers. Okay. I hope you know what outliers are. Under plots, I'll uncheck this term and leave. I will check histogram and I'll check normality plots with test. Can you hear me?
yes, we can.
Yes, I'm saying that the network doesn't want me to show this thing. As I just want to show it, it's just going off. It's just going off. Okay, I'm showing the output screen. I don't know if you can see the output screen.
Mm-hmm.
Can you see?
Yes.
All right, so this is the output screen, and then you look at the Shapiro-Wilk test where I am now. You can see this test of normality, right? We have the Kolmogorov-Siminov, and we have the Shapiro-Wilk. So in this case, when it has to do with normality and some other tests of as some other assumptions test in SPSS or in statistics, the interpretation here is opposite to what we normally know for p-value, which means that this p here, as you're seeing, this is a p-value, right? This p here like this. When it
Mm.
is significant, it rather means that the data is not normally distributed. So you interpret it opposite to your normal way. The normal way you always interpret p-value. Because normally in p-value, we know if your p-value is, if you're using 95% confidence interval or 95% or the 0.05 alpha, we know that any value, any p-value less than 0.05 is considered statistically
Ay,
right? My
So
apologies.
if I understand what it means for this Shapirovic test and the other, the new hypothesis is assumed to follow a normal distribution.
Voila. So in this case, we're
Then now,
accepting
then I-
exactly that's the statistical explanation.
okay.
The null hypothesis is following the normal distribution. So we're
Normal
actually checking for the null hypothesis here. You understand? Which means if your data is not normally distributed, as you can, is not significant as you can see here, it means you are rejecting the null hypothesis. Which means that your data does not follow a normal distribution. So look at the histogram. How can you judge this histogram? Even though our Shapirovic is not showing that it is normally distributed, but does your histogram look somewhat like a bear shape? George, you have the histogram in front of you. What can you say about this histogram?
Hey, to me, it looks like a bear shape, but from the little practice I've done, I always go to that plot.
Mhm.
When I look at the graph, I go as far as that plot in order to see if my judgment on the histogram is good.
Yes.
But now I'm not understanding why the plot shows that the maximum of the points, they are concentrated along the line. But that the test is telling us to reject the null hypothesis, which shows that it's a normal distribution.
Yes, the Shapirovic test is in the perfect sense of it. So if this data was perfectly
Okay.
normally distributed, Shapirovic will not be significant as you saw it up there. So it is not
Yes,
perfect
I
because you
see.
can see that the highest points, the highest birth weight here is around 3,000 grams, which is not the middle of the histogram. The middle is supposed to be somewhere here, right? How we can see my
Okay.
cousin.
Yeah,
Yeah, the middle should be somewhere around
yeah,
3,400. So we expected this sharp up
yeah,
here
okay.
to be maybe this way. But in the and then this tail
Near
here
the middle.
is also long to the right. This tail this way is shifted to the right a bit, kind of skewed a bit compared to this tail. Because these are the tails now. Remember this thing. So it's not perfectly normally distributed, but it is not really that skewed. Because if majority of these points were shifted right here to the left, we'll say it is skewed to the left. Yeah, we can say it's a bit skewed to the left, but not really that skewed. So we can use our own judgments and maybe consider. And if you look at this normality plot with test, you will see that this dot line almost around this line. This is another way to judge it there. When your dots, this your dots lie just close to this line. Yeah, you can also judge that it is fairly normal. But you can see some few dots away from the line, as you can see here.
Yeah.
Yeah, so it is fairly normally distributed. Not perfectly, but fairly. And then our box plot shows that we have some outliers. Remember, we said outliers are what? Values are either too large or too small, or that they stand out. In the business sense of it, outliers are big businessmen who stand out in the industry, right? Like Apple. Apple is an outlier because it stands out. Microsoft, big, huge profit. But in the case of the data science, it is a bit negative if you have outliers because these are the ones that will skew your data sets, push it ahead on and make your mean not to be true because they are either too small or too much. So we have some outliers here, as you can see. Times we have some, and they're up here above this whisker. So it means that we have
Mm-hmm.
if you want to get the average birth weight, you should not look at the mean in this case because the mean can be skewed because there's some birth weight that are overly high. As you can see, and this 157 does not mean that the birth weight is 157. These are just placeholders, okay? If you want to know the exact birth weight that 157 stands for, I think you have to come up here. There's one. 157. It was the highest now, so it was above the whisker. Yeah, 157. Can you see? 157. The bed weight is 5,000 weight grams. So it means that you may want to go now and change this 5,000 grams to the mean. Okay. So that your data is not really skewed.
Mhm.
Another way is that you don't consider the mean, but you consider the median. Because the median in this case will speak better than the mean, since the mean can be skewed by these large values, right? And the median is this number, this value, this thick line in the middle here of this box. And if you follow its y-axis right here, it's maybe 3,300 grams, right? If you want to extra think here. But to see the exact median, you should come right up and you see the median. Where is it? Is it there?
3,200.
Yeah, 3,200.
Yes,
Uh,
3,000.
200. But the mean is 3,284. So this extra 84 is because of maybe those outliers. But that's not what that's not our concern for now. Our concern is that it's fairly normally distributed. And so we are going to go ahead with our t-test. All right, I think we'll do just that t-test. Maybe next week we can go on with the other ones because this Pearson correlation, BMI and newborn weight.
So,
Yes,
can we, if we proceed with the test without removing those outliers, it will not process, right?
it will process.
It will process, okay. Okay.
Yes, it will process. And another thing too is to check if those outliers can really affect your data set. We're still on this output, right? The output window.
Is that for the is that for the case for just for the independent or even for the dependent? Because like I did one processing like that and it gave me an error saying that I cannot process with the presence
No,
of
if you
outliers.
have categorical variable, what will you be needing this thing for? Don't need it now. We're doing this thing because we want to do a parametric test. And in that parametric test, one of our variables is a continuous variable. The other one is categorical now. The mode of delivery is categorical. So you don't need it here. You don't need to, you cannot get the mean of a categorical variable with a median. It's either is yes or no. It's either you gave birth to the normal vaginal delivery or it was through CS. So you cannot use that one here. Maybe that's why
Where the
you had that
problem?
error.
Yeah, because I actually coded the values, but I did not change the string to numeric.
That's it. SPS will not accept because SPS is still that the data type is string, but you are putting this thing. So at times you even remove the thing and put dot 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 dot, and you and remove all your data. So the rule of thumb is that you don't change the data type to numeric when you have not yet coded. Because we actually went and converted the delivery mode to one and two, right? Before we went back to variable view to change the data type from string to numeric.